Hello, welcome to this tutorial about using Georgia on your local desktop. So Georgia is a statistical emulator that can mimic the behavior of a glacial isostatic adjustment model that can allow you to calculate post-glacial sea level change from 25,000 years ago to present day based on your own ice model within just a few seconds. So once you successfully install Georgia in your computer, you will be able to see this portal. So if you don't know how to install it, please check the previous tutorial about installation. So this is a specific app we designed to explore the North American ice sheet impact on post-glacial sea level change. So in our portal, you can find several slider bar which we use to control our own synthetic ice model of North American ice sheet, as well as our visualization time. And on the right hand side, you will find the ice history evolution, ice volume history evolution from 25,000 years ago to present day. The mean ice geometry, which is generated by averaging the 9 ice model we collected from previous publication. And this is the mean ice geometry we created by changing the slider on the left hand side. And the last figure shows the difference between mean ice geometry and the synthetic ice model we generated at 21,000 years ago. If you want to change the plotting time, you can just you can change the plotting time slider bar here. So if I want to change it to 13, you can find that I'm showing this ice geometry at 30,000 years ago instead of 21,000 years ago. So now you can see that our synthetic ice model, as this black solid line here, is a result by combining the ice 5G and the ANU ice model. So if I don't want to use the ANU model, I want to use the Han 2021 model, I can change the second slider from which is an index slider, which tells the model which ice model you are using. So I can change it to 8, which is Han 2021 model. So that's why you can see here I'm using Han 2021 model here, and my synthetic model is averaging the Han 2021 model and ice 5G ice model. And then we can adjust the relative weighting of these two ice models. So if I want to make my synthetic ice model looks more similar to Han 2021 model, I can change the relative weighting slider bar here from 0.5 to 1. So that's why you can see that our synthetic model looks much more similar to Han 2021 model now. And for each time slices, you can plot the all of the available ice models geometry by clicking this plot all portal here. So that's why you can see different ice models geometry at 13,000 years ago. So once we are happy with our and lastly, we can change the temporal slider bar to make our synthetic ice model melt either earlier or later between 1 to 1,000 years. So if I change this slider bar to 1, you can see that this synthetic ice model melts much later, 1,000 years later compared to before. I can change to 3 to make it more obvious. So you can see that this ice model melts much later, right? And once we are happy with our synthetic ice model here, we can click run emulation here. And after a few seconds, you can see that the emulation is complete. So now we can plot the emulation results by click this button here. So now you can see a figure showing you the ice history, the mean ice history, the synthetic ice history, the difference between them as we saw before. And this is the emulated global relative sea level change at 21,000 years ago. And this is for the mean ice history. This is for our own ice model. And this is the difference between them. So it should be mentioned that although we only generated the North American ice sheet, it is automatically paired with the mean ice geometry for North American ice sheet, Eurasian ice sheet, and the Antarctic ice sheet. It should be mentioned that although we just generate the North American ice sheet, it can be automatically paired with the Eurasian ice sheet and the Antarctic ice sheet to generate a global ice sheet history. And note the ice thickness plotted here is ice thickness compared to present day instead of the absolute ice thickness. And then you can see 3 plots here showing you the eustatic sea level history or the barostatic sea level history for our mean ice model, our synthetic ice model, and the relative sea level change history at Barbados and Tahiti, which you can find location here. So lastly, you can download the results by click this button. So once you download the results, you will be able to find the longitude, latitude of each grid, the ice history, and relative sea level change history.